Hello, hello, and welcome to another video on theoretical lead through of row and array comparisons, and we will cover set returning functions as well. That is section 9.26. So I yet have to prepare the example for this. So if there is an example, we will see it tomorrow. Now, there is a very important announcement I'm going to make is that after set returning functions, that is section 9.26, we are going to skip rest of this chapter. 9.27, as you can see, is system information functions, and 9.28 is system administration functions. 9.29 is trigger functions, event trigger functions, and statistics information functions. So these functions which you see here, the 9.27, 28, 29, and 30, these are rarely used in day-to-day querying. We don't normally use that. So I will let you read those on your own, and we will take a detour back to what we were doing, that is querying. And we will do lots of examples, okay? So from this theoretical side, we'll take a detour and we'll go on the practical side. We'll do a lot of querying. And once we are done with the querying, we will come back to this document again, okay? And then we will cover um, the chapters of 5, 6, 7. That is, I'll read it, data definition, data manipulation, and queries. That is chapter 5, 6, and 7. And then we will cover type conversion, chapter 10, 11 indexes, 12 full text search, and possibly concurrency control, chapter 13, chapter 14, performance tips, chapter 15, parallel query, and we will cover chapter 36, not 36, 37 triggers, 38 event triggers, 39 the rule system, ALSI, and 40 procedural languages, and 41. So 6 chapters from server programming, that is 36, 37, 38, 39, 40, and 41. Although you can do PLP, PGSQL in Python also, so that will be PL Python or TCL or Perl, but we will not cover Python, Perl, or TCL. Maybe we will cover Python, but TCL and Perl we are definitely not going to cover. We can do PL Python, okay? And that would be the end of this playlist. So that is the announcement I had to make. So let's go through the last theory video, that is this one, for a long time. Okay, so we are going to start with row and array comparisons. This section describes several specialized constructs for making multiple comparisons between groups of values. These forms are syntactically related to the subquery forms of the previous section, but do not involve subqueries. The forms involving array subexpressions are PostgreSQL extensions. The rest are SQL compliant. All of the expression forms documented in this section return Boolean results. Give me a moment. So first one we have is n, that is expression in value. The right-hand side is a parenthesized list of expressions. The result is true if the left-hand expression's result is equal to any of the right-hand expressions. This is shorthand notation for expression is equal to value or expression is equal to value 2. Note that if the left-hand expression yields null, or if there are no equal right-hand values and at least one right-hand expression yields null, the result of the n construct will be null but not false. This is in accordance with SQL normal rules for Boolean combinations of null values. Then we have expression not in value. So the description is kind of same. So expression not equal to value, not equal to value 2. So this description is also the same. Okay. So I'm not going to read the repeated thing. We have a tip: x not in y is equivalent to not x in y in all cases. However, null values are much more likely to trip up the novice when working with not n than when working with n. it is best to express your condition positively if possible. Then we have any expression operator, any array expression, expression operator sum, array expression. The right-hand side is a punch-side expression which must yield an array value. The left-hand expression is evaluated and compared to each element of the array using the given operator, which must yield the Boolean result. The result of any is true if any true result is obtained. The result is false if no result is found, including the case where the array has 0 elements. If the array expression yields a null array, the result of any will be null. If the left-hand expression yields null, the result of any is ordinarily null, though a non-strict comparison operator could possibly yield a different result. Also, if the right-hand array contains any null elements and no true comparison result is obtained, the result of any will be null, not false. Again, assuming a strict comparison operator, this is in accordance with SQL's normal rules for Boolean combinations of null values. Sum is a synonym for any. Then we have all expression operator, all array expression. So the description is kind of same. The right-hand side is a parenthesized expression which must yield an array value. The left-hand expression is evaluated and compared to each element of the array using the given operator, which must yield a Boolean result. The result of all is true if all comparisons is true, including the case where the array has 0 elements. The result is false if any false result is found. If the array expression yields a null array, the result of all will be null. If the left-hand expression yields null, the result of all is ordinarily null, though a non-strict comparison operator could possibly yield a different result. Also, if the right-hand array contains any null elements and no false comparison result is obtained, the result of all will be null, not true. Again, assuming a strict comparison operator, this is in accordance with blah blah blah. Then we have row constructor comparison, row constructor operator, row constructor. So we have encountered row constructor earlier when we were doing the operators, I believe, or I think subqueries. I don't remember exactly. Each side is a row constructor as described in section 4.2.13. So let's go to 4.2.13 and see what a row constructor is. A row constructor is an expression that builds a row value using values for its member fields. A row constructor consists of a keyword row, a left parenthesis, 0 or more expressions for the row field values, and finally a right parenthesis, for example, select row 1, 2.5, and so on. The keyword row is optional when there is more than one expression in the list. A row constructor can include the syntax row value of star, which will be expanded to a list of the elements of the row value, just as occurs when the dot star syntax is used at the top level of a select list. For example, if table T has column F1 and F2, these are the same. Select row T dot star 42 from T. Select row T dot F1, T dot F2, 42 from T. Before PostgreSQL 8.2, the dot star syntax was not expanded in row constructor, so that writing row T dot star 42 created a two-field row whose first field was another row value. The new behavior is usually more useful if you need the old behavior of the nested row values. Write the inner row value without dot star, for instance, row T, 42. So that's what the row value is about. Okay, let's come back to where we were. Okay, here. All right, so the two row constructors must have the same number of fields. The given operator is applied to each pair of corresponding fields. Since the field could be of different types, this means that a different specific operator could be selected for each pair. All the selected operators must be members of some B-tree operator class or be the negation of an is equal to number of a B-tree operator class, meaning that row constructor comparison is only possible when the operator is equal to, not is equal to, less than is equal to, greater than is equal to, or as the semantic similar to one of these. The is equal to and not equal to cases work slightly different from the others. Two rows are considered equal if all their corresponding members are non-null and equal. The rows are unequal if any corresponding members are non-null and unequal. Otherwise, the result of row comparison is unknown or null. For the less than is equal to, greater than, and greater than is equal to cases, the row elements are compared left to right. stopping as soon as an equal or null pair of elements is found. If either of this pair of elements is null, the result of the row comparison is unknown or null. Otherwise, comparison of this pair of elements determines the result. For example, row 1, 2, null less than row 1, 3, 0 is true, not null, because the third pair of elements are not considered. Row constructor is distinct from row constructor. This construct is similar to not equal to row comparison, but it does not yield null for null inputs. Instead, any null value is considered unequal to distinct from any non-null value, and two nulls are considered equal, not distinct. Thus, the result will be true or false, never null. Row constructor is not distinct from row constructor, so it has the same description. We will skip this. Then we have composite type comparison, record operator record. The SQL specification requires row-wise comparison to return null if the result depends on comparing two null values or a null and a non-null. PostgreSQL does this only when comparing the result of two row constructors as in section 9.25.5 or comparing a row constructor to the output of a subquery as in section 9.24. In other contexts where two composite type values are compared, two null field values are considered equal and a null is considered larger than a non-null. This is necessary in order to have consistent sorting and indexing behavior for composite types. Each side is evaluated and they are compared row-wise. Composite type comparisons are allowed when the operator is equal to, not equal to, less than equal to, greater than or greater than equal to, or has a semantic similar to one of these. To be specific, an operator can be a row comparison operator if it is a member of a B-tree operator class, or is the negator of the is equal to number of the B-tree operator class. The default behavior of above operation is the same as for is not distinct from the row constructors. To support matching of rows which include elements without a default B-tree operator class, the following operators are defined for composite type comparisons. Multiplication is equal to, multiplication not equal to. It could be something different. I am not sure about this star thing here. These operators compare the internal binary representation of the two rows. Two rows might have a different binary representation, even though comparison of two rows with the equality operator is true. The ordering of rows under these comparison operators is deterministic but not otherwise meaningful. These operators are used internally for materialized views and might be useful for the other specialized purposes such as replication and B-tree deduplication. They are not intended to be generally useful for writing queries though. Okay, now we have section 9.26, that is set returning functions. This section describes functions that possibly return more than one row. The most widely used functions in this class are series generating functions as described in table 9.69 and 9.70. Other more specialized set returning functions are described elsewhere in the manual. See section 7.2.1.4 for ways to combine multiple set returning functions. First, we have generate series start integer. Start is an integer, stop is an integer, step is an integer, gives a set of integers. Then we have generate series, start begin, stop begin, step begin, set of begin. Generate series, same but numerics. Generates a series of values from start to stop with the step size of step defaults to 1. Then we have another generate series where we have timestamp and step is an interval, which will return a set of timestamps. Then we have generate series, start timestamps with time zone, stop timestamp with time zone, step is interval, and it optionally takes a time zone as text and returns set of timestamp with time zone. Generates a series of values from start to stop with the step size of step. In the time zone aware form, times of day and daylight saving adjustments are computed according to the time zone named by the time zone argument or the current time zone settings if that is omitted. When step is positive, 0 rows are returned if start is greater than stop. Conversely, when step is negative, 0 rows are returned if start is less than stop. 0 rows are also returned if any input is null, and it is an error for step to be 0. Some examples follow. So we have generate series 2, 4. So series will give us 2, 3, 4. Then we have 5, 1 minus 2. step is -2, so it will give us 531. Then we have generate series 4 comma 3, so it will return 0 rows. Then we have 1.1 to 4. With the step of 1.3, it will give us 1.1, 2.4, 3.7. Then we have select current date plus s.a as dates. From generate series 0, 14, 7 as SA. So you see, it will have the first value as 0, second value is 7, and third value is 14. So current date will, this will be added to current date. So it seems when the code was run, it was 5th February 2004. And then 7 was added, it became 12. And then 7 again was added, it became 9. Then we have timestamp example. From 1st March 2008 to 4th March 2008, from midnight to noon, and our interval is 10 hours. So see 10, 20, and then 30. 30 would be 30 minus 24, 6, plus 10, 16, and so on. And similarly with timestamp period, and here optional time zone is given New York. All right, so you can see that. Give me a moment, please. Okay, now we are looking at subscript generating functions. Generate subscript array, any array, dimension integer, return set of integer. Generates a series comprising the valid subscript of dimension of the given array. Generate subscripts array, any array, dimension integer, reverse boolean. It returns set of integers in reverse order. Generate subscripts is a convenience function that generates a set of valid subscripts for the given dimension of the given array. 0 rows are returned for array that do not have requested dimension, or if any input is null. Some examples follow. So we are given 4 values as integer with a dimension 1, and we have to generate the subscript. So subscript should be 1, 2, 3, 4. And then we select star from arrays. So presenting an array, the subscript and the subscript value requires a subquery. Okay. I'm not sure what is arrays here. All right, let's ignore it. Select A as array, S as subscript, AS as value. From select generate subscripts A comma 1 as S from arrays. So again, I'm not sure what arrays it is referring to. Right. So I will come back to this on this example. Okay. I'm not really sure what arrays is here. And then we have unmeshed. Does it contain the, okay, it does not have arrays. So it is a PLPGSQL function. So we ignore this as well. When a function in the from clause is suffixed with ordinality, a begin column is appended to the function's output column, which starts from 1 and increments by 1 for each row of the function's output. This is most useful in case of set returning functions such as unmeshed. So select star from pgls underscore dir dot with ordinality as t ls comma n. Okay, so that gives the pg files, and the ordinality will mean that it will increase sequentially to 19. So I'll come back on these things. This we will skip because we have not yet studied PLSK functions. I'll look at these two queries that what arrays mean in this. I'm not sure about the arrays part of this. Okay. So with this, we end the theory for now. As I said, we will not cover section 9.27, 28, 29, 30, and 31. So for a lot of time, we will indulge in the practical aspect of SQL querying. Theory-wise, we have covered quite a lot of theory. We covered chapter 8 and chapter 9 fully. So it has been a joy to read the documentation. I still believe that we should go for chapter 4, 6, 7, but I know that most people understand the very basics of SQL, so it is best to learn by example. That is my notion. Reading theory, I understand the importance of theory. That's why I went for chapter 7 and 8. Okay, but still, I believe that learning by example is probably the easiest approach. Okay, and I don't know who is listening to or watching the video. What is your expertise level? Some of you may be beginners, some of you may be intermediate, and some of you may be advanced. But still, I understand that whatever I'm covering is useful for all the level types. So we will resume from, we will, I'll try to show some examples of this um, row comparison operators with arrays, row array comparison operators, which we did. That is this section 9.25 and 9.26. 9.26 does not need many examples. Okay, so I'll present examples of 9.25. Okay, 26 is pretty simple. For 26, I'll try to see what arrays mean in this. All right, the one which you did. Okay. So with this, I will end this video here, and I hope that you have enjoyed this entire playlist of, or rather theory of PostgreSQL or SQL. So, and found it useful and you learned something. So starting from the next video, we will look at the examples, and we will have our old employees table, if you remember that. Okay, let me show you. Okay, so what we had was CD, videos, Postgres. We had an employees table here. Okay, not here. Let's start out SQL. So we had this employees table. Okay, let's revisit this. So this is what we had, and we had covered some queries. We had created some indexes, JSONB, and all that we did. So we will, this PG crypto thing is there, and POLS and all we did. So we will take these two tables, department and employees, and we will perform querying on this. Okay. So thanks a lot for watching the video, and I'll see you tomorrow with examples of set and array comparison. So once again, thanks a lot for watching the video. Stay curious, keep learning, and most importantly, enjoy.